Welcome to EmComm Solutions. Jake here. I have an exciting interview for you today with the CEO of Beechat Network Systems, and we're going to take a look at their Kaonic 1S, a mesh radio, and see what sets it apart from other mesh radios that are on the market. So let's take a look.
All right, so today I have Nicholas from Beechat Network Systems. He's CEO and founder. We're going to talk a little bit about the Kaonic S1. Start off with just a short introduction from you, Nicholas.
Hi, everyone. I'm so glad to be here, Jake. Yeah, thank you for the introduction. I am the CEO of Beechat, and I'm leading the product development and the vision behind the company. The main idea behind Beechat is that we are building cryptographic radio systems that allow peer-to-peer communication and hopefully change the world through that. We are right now starting with tactical communication, but we actually want to go into consumer devices in the future as well. And we're already taking steps towards that. And what we're seeing now is that there are a lot of technologies that would allow, this decentralized communication between humans without control, a centralized control from internet service providers and so on. But it's mostly in the military areas that this is it's only limited to the military areas and military grade products. And what we're doing is we're building a completely open source software firmware system based on our hardware that will allow people to develop who knows what. But long story short is very powerful radio systems that are highly performant and at a fraction of the cost.
Very cool. All right, so we'll start off here. First question really is, you kind of talked about it a little bit already, but what's inspired the development of the Kaonic 1S? And then, how does your team's vision align with the growing need for decentralized off-grid and sovereign communications?
We actually started Beechat. When we started Beechat, we wanted to build a handheld device that would decentralize communication. And the idea was, if there's a blackout, if comms go down, if anything happens, you have a way to securely exchange data that is not a walkie-talkie. And walkie-talkies are great in what they do. The problem is that unless you're very technically savvy or you're a ham, amateur radio, then it's very difficult to store data, to visualize data, to send over images. There's things, of course, you can do if you're technical. But for the average person, it is very hard to do that. And so voice is really the only application. So you can't really send files easily. You can't send video. You can't do most of the things that people are used to doing. And then we found out that, actually radio modules that are free to use, meaning that you don't require a license to use, exist. And so we decided to build a product using that technology. Come to find out, there were quite a lot of problems. Sourcing was one of them. These chips were constantly out of stock. But not only that, then the performance, we realized that it was pretty bad. It wasn't what we expected. We expected at least 4G or 3G kind of connectivity. But we came to find out that in some of our field tests, we were struggling to even get a few hundred meters in distance. So that wasn't something that, I'm talking in an urban scenario, that wasn't something that we expected. And then at that point, we kind of realized that we needed to take a step back and see what it is that we can actually do. How can we actually disrupt and achieve our vision of true decentralized communication? Because at that stage, we didn't believe that technology that's just off-the-shelf IoT modules meant for agricultural sensing, IoT type of data, was going to be useful. Of course, we saw a lot of projects happening like Mishtastic, very interesting stuff. But again, the performance was lacking. You can do simple texting, you can have map updates over ATAC, stuff like that. But you're not able to have the modern applications that we're used to. So having that in mind, we started doing a lot of research, and we found that there are systems that do allow that kind of performance. But again, they're in the military sector and they're black boxes. You have no idea what's going on inside them. They're tens of thousands of dollars, and they're very hard to get, again, unless you have tens of thousands of dollars.
Yeah.
And they're not really open to the average person, and they're not meant for the average person, honestly. They're tactical devices, right? And at that point, we realized, we need to bridge the gap in the market. And so that's where the Kaonic 1S comes, where it's our flagship product that we introduced early this year, which is this single board computer here. And this single board computer, it is a single board computer that is as easy to work with as what people are used to, like a Raspberry Pi type device. And it's running Linux. And it's all open source in terms of the software, the firmware. So the idea is we are going to provide all the software, all the firmware, all the FPGA code, open source and freely accessible under the MIT license. And we don't know what people will build with it. And that's cool. And that's what kind of is exciting us as a company is we really truly wonder what will people build with this, because suddenly people will have in their hands a device that can do the advanced things that only military grade devices typically do, like MIMO, multiple input, multiple output, that is combining multiple radio streams in order to improve performance in urban scenarios. So that's a little bit of background on the Kaonic 1S.
Yeah, very cool. And that leads us into the next kind of, and you already touched or hinted on the fact that the, kind of differences between this device has versus like a LoRa, Meshtastic device. What are, obviously we all know, or those that are already use Meshtastic or have, that you're basically, limited to text and location data, maybe a little telemetry data, but all small data packets. But with this, you're talking like voice, right? And some other capabilities, if I understand correctly.
Absolutely. And that's not to say that, we completely replaced LoRa. Not at all. In fact, I think LoRa still has tons of use cases, especially if you're looking for something that's super cheap to get started with. I mean, as you mentioned, with LoRa, you can get texting done and perhaps very slow file sending as well, map updates. But what we're doing with Kaonic is fundamentally different, as you mentioned. We are looking at more than 1,000x in terms of data rate. So LoRa, is anywhere between half a kilobit all the way up to 50 kilobits a second. And we could do, with plugins, we could do more than 10 megabits a second. So that would allow HD video to flow through the mesh network. And the important thing is that a lot of these kind of features, we are opening them up to the community. So of course we are heavily investing in the software. We already have live audio calls working on our current system, and we have so many optimizations to come. So apart from the new capabilities that could be done with this type of device, like new applications like audio, live video. The thing is, it also has better range in urban scenarios because we have direct access to the actual radios themselves. Even LoRa radios, unless you're very, very technically savvy, you can't really touch the baseband unless you're making your own modules, your own PCBs. You can't touch the baseband. The baseband is kind of, think of it like the processor that is kind of doing the translation between an analog signal and a digital signal and kind of getting data out of that.
Okay.
Whereas we are going to be launching this tiny device. Not sure if you can see it. This tiny device. So this tiny device plugs into the Kaonic 1S. It just clicks in. And what it allows you to do is it allows you to combine the two radio streams into one. You can double your data rate and you can get better range in urban scenarios. So that's a massive thing, but it's not, we didn't invent this. And this is already, it already exists in 4G, 5G. We use it every day without even knowing it. And tactical grade radios use it as well. IoT radios don't use it. Meshtastic doesn't use it. But the difference with us is that we're using it, but we're also making it open source for everybody to be able to add new algorithms, new improvements. Yeah.
Very cool. Yeah. And, I know a lot of people, obviously, including myself, that use Meshtastic, but then they kind of have, depending on what their situation is, they're carrying a Meshtastic device and they're carrying a handheld walkie-talkie type for voice because they don't have those capabilities. And we'll get into some of the other stuff here in a little bit. This rolls us into kind of real world testing, or just what kind of have you seen, and either stuff you've done in the lab or out in the field.
Yeah, that's a great question. We've done field tests. We've done quite a few field tests. I live in London, so as the CEO, I've been conducting quite a lot of field tests in urban scenarios around Canary Wharf, which is an area with skyscrapers, around multiple parks. And I've seen what I would consider really good performance compared to other systems. So we've tested LoRa, we've tested XB, and with those systems in the urban scenarios, we actually struggled to get more than a few hundred meters if there was some kind of disruption, some kind of foliage, some kind of concrete. But due to the modulation that Kaonic uses, OFDM, we are able to, well, that modulation, it splits the signal into multiple subcarriers, and in a way kind of is much more resilient to reflections and to foliage, to disruptions. So I would say that through our testing, we figured out that Kaonic is built for urban tactical scenarios where you will see foliage, you will see concrete, whereas LoRa, I think, is really, really good for very long distance links. However, I think in an urban scenario could be much better if you had this MIMO capability. We have this MIMO capability. We'll be rolling it out soon. Just the radio itself, just a detail. So the radio itself, if it doesn't have an FPGA, you can also use it, and it also has OFDM. OFDM is the built-in modulation of the radios. Is one of the modulations that's built into the baseband that's available to the radios. The FPGA is simply better in terms of that. It has more noise correction, forward error correction. It has other algorithms. However, the capabilities are very, very interesting of OFDM, because what it allows you to do is it allows you to have more data rate in a tactical scenario. And by having two radios, we're actually able to have multiple streams. So on Kaonic, if you don't have an FPGA, you can be transmitting both radios at the same time. As long as you have enough frequency separation, you can do that. So you have to have 100 megahertz frequency separation in order to transmit. With the FPGA, it doesn't matter. You can transmit. It's actually transmitting at the same frequency. It's kind of combining the signals into one. If you are using the one, you can also use one radio, one RF front end for 2.4 gigahertz, and another one for sub gigahertz, like 900 megahertz. You can kind of switch them up, right? So you have choices of what you can do. Whereas with LoRa, you're really limited. And typically, if you get a radio device with LoRa, it just has one radio, maybe two, if you count the Wi-Fi Bluetooth radio, which I would count as a radio. But you don't benefit from that diversity of multiple radios.
Very cool. Yeah, as you mentioned there, in the urban setting is obviously one of the most challenging for all types of radios. So the feedback you're getting as far as the ranges sounds really good, and something I'm sure a lot of people will be interested in. So moving on to the cryptography, the kind of post-quantum world that everyone's talking about, at least on YouTube, I know. You guys have kind of stepped into that space a little bit, right? With on top of the AES 256-bit encryption. Am I correct on that, or can you elaborate more?
Mm-hmm. So Reticulum, the mesh networking protocol we're using, recently rolled out AES cryptography, AES encryption, an upgraded AES encryption as to how it was before. In terms of so we're using that. We're using that. In terms of the post-quantum, we haven't rolled that out yet, but because everything is modular in our system, it's going to be a matter of replacing one library for the next. And we're going to get to that in a second. But because we're using Rust programming language, it's going to be relatively easy for us to switch it out. At that point, it's going to be we won't be able to call it Reticulum. It's going to be something else. But that's we're basically looking at, okay, what set of cryptographic primitives can we roll out in the most agile way, depending on what people need, right? So some people need just the basic Reticulum cryptography stack. Some people have a requirement for FIPS 143 compliant devices, and so that needs a completely different type of cryptography stack available. And of course, as a company, what we're doing is we're kind of trying to fulfill those needs in order of priority. So we're starting off with the reference implementation that is available in the mesh networking protocol that we're using. And then we're going to be building up all the way to post-quantum cryptography, and we're planning that to roll out in July.
Oh, very cool. And so when you said a quick swap out, I think you used the term library, we're just talking basically a software or firmware update or something like that, correct?
Exactly, yeah. And people would be able to select what they want to use. Important to note that once you switch your library, your cryptographic algorithm that you're using, it won't be compatible with people using another cryptographic algorithm. So for example, if you're using Reticulum and on a Kaonic 1S, and then you, through the settings, you try to enable the post-quantum upgrade, it's not going to be compatible with the other nodes. So it would be a more limited type of scenario, a more customized kind of requirement.
Yeah, and I think what you're doing there is pretty groundbreaking. I know there's probably lots of conversations going on in many spaces in the military government sector, but I'm sure a lot of them are highly concerned about the future and what protocols they're using now may not be sufficient in the future to remain encrypted in their communications. So I know this is something that will probably continue to grow, and then demand for it will grow. So
absolutely, especially as the years go by. I remember I first heard about the threat of quantum computers to cryptography in 2020. I can share the article with you that first inspired me to kind of figure out how to protect against it. But it was a study by Deloitte that was quoting that or was showing that Bitcoin can be cracked relatively soon. That was in 2020, I believe, and it was quite scary because it's not about Bitcoin. It's about all the other systems that use that type of cryptography. And those papers that I saw were basically talking about this cryptography that we're using today, elliptic curve cryptography, being broken. Lower band estimate 2027 and higher band estimate 2032. I think that at this point, the quantum computing space is evolving at an exponential pace. It's actually evolving faster than traditional classical computers in terms of processing speed. So it's more exponential in terms of its growth. So it's very interesting, and it's 2025 now. 2027 is around the corner for the lower band estimate. Yeah. And in fact, NIST, part of the U.S. government, has kind of said any kind of official network or cryptographic implementation should be quantum proof by 2024, I believe. So we're already late on that.
Just a little, yeah.
Yeah. So it's pretty crazy. But again, a lot of people then are doubting that. A lot of people don't believe in the cryptography. There's a lot of debate as well as to, is the cryptography actually secure? Because some of the cryptography, some of these cryptographic libraries, people don't really want to trust government implementations or government approved cryptographic primitives. That's another opinion, and totally valid as well, because who knows if there's some kind of backdoor that we're not being told. So likely. We kind of so at Beechat, we're kind of providing we're providing the hardware, and we're providing multiple implementations, and people can kind of choose what they want.
Yeah, the theme here that I've obviously seen with this is there's a lot of adaptability to this device, that people can make changes, update as necessary, making it very modular, and
they own it.
Yeah, exactly. It's not one of those devices you buy that's all locked down, and when it becomes a little outdated, it's just, well, now you need to go buy something new because it doesn't meet your current requirements anymore. So I think that's going to be a good selling feature for a lot of people. So Reticulum, which is obviously something that a lot of my audience is familiar with. I've dabbled with it a little bit, but it gets, based on time constraints and dedicating myself to other things, I haven't really figured it out. But how does it kind of improve the Kaonic 1S as far as its, to be a robust mesh network, and what role does it play in that device?
Well, in a way, we didn't really have a choice to other than using Reticulum, because it's one of the very few open source mesh networking protocols out there. So since we're building our own radio module, we're like, okay, what kind of mesh networking protocol are we going to use? What's out there? And we started doing some research, and then there's Batman, there is OLSR. Those are pretty old, but still used quite a lot, those protocols. And then we came to find out Reticulum exists, and we were so impressed by Reticulum because it's truly groundbreaking in its concepts. Reticulum is so much more than a mesh networking protocol. At its core, it's a global networking stack. So you could create global networks with this. Reticulum itself is not a network. Reticulum is a software stack that allows you to build networks. So with Reticulum, you have total control down to the packet level, at the lowest level. what it is that's happening in your radio network. So that was super powerful for us when building a radio module. And in difference to, LoRa or something like that, LoRa, for example, LoRa, Bluetooth, Wi-Fi, everything pretty much uses MAC addresses. And MAC addresses can be spoofed. And that is a huge problem. So you have to then have encryption built on top. You have to then exchange your keys somehow else. Like in Meshtastic, you have to exchange your keys. But with Reticulum, at the very core of the networking protocol, an identity is a key. So you can even have multiple identities on a single device. And think of it more like an email in a sense. So you could have, so for example, on Kaonic, one of the things that we're looking forward to build is we're creating the mailbox feature. And the mailbox feature, what it's going to allow you to do is multiple devices will be able to connect to the Wi-Fi access point on the Kaonic 1S. And each, phone app or app on the or program on the laptop that is trying to access the mesh network will have their own identity. You can have multiple identities as well. And someone around the world could send you a message and you would receive it. How? Well, of course, you need somehow, those messages need to be routed somehow. But for example, let's say you have my username, you have my public key. So you can send, so you can be on a mesh network somewhere in the States, and that message can jump all across through the mesh network until it reaches an internet connected node. Then it jumps over the internet through multiple servers, and then it eventually reaches a server that's somewhere here in London, and it enters the mesh network here, and then it spreads through the nodes, and it eventually reaches me. So that's a type of network that we're looking at with Reticulum. So we're so impressed with Reticulum. We believe it's truly the future of communications. It's so much more efficient as well than anything else. So one of the problems with a lot of protocols is that about 10 to 60% of the protocol itself is overhead. So it's control packets, and Reticulum has 0% control packets. So you need much less data rate in order to achieve the same thing with Reticulum. And even at the lowest level as well, everything is encrypted and digitally signed, so it's just secure by default. Whereas you don't get that with other protocols. So it's a combination of the flexibility that it allows us as radio manufacturers, the security, the inherent security, and the scalability, which is superior to military grade radios. That's the thing. So you're getting more bang for your buck, more than a $10,000 military grade radio. They don't have that. They're limited at 10 hops, 10 mesh hops. I believe LoRa is limited to 7 network hops, but Reticulum has 128 mesh hops by default, and that's simply a part of the packet that could be changed to 1024 or whatever. So it's just so much more scalable. We're talking planetary scale.
Yeah, definitely. I need to spend more time learning about it. It as I have had several conversations with other people online, and they're doing crazy stuff with Reticulum. I think there's even one guy was telling me that he's got something set up where he's integrated it with his amateur radio stuff, and so he's obviously got a little more knowledge than I do on that system. But so you kind of touched on this already, but and we touched on this a couple times, in modularity, and you mentioned the FPGA socket. What are some of the sensors or things you can integrate with that users might be interested in?
Well, a lot, but keeping it simple. Keeping it simple. The Kaonic 1S by default you can plug in a LiPo directly into the Kaonic 1S. It has support for smart batteries, meaning that batteries that are have balancing circuits, which is a super powerful feature. If you are trying to build a device, if you have a company or you or a person trying to build a handheld, you would want an easy way to connect battery to the device, and we've added the smart battery feature to that, where even if you have a multi-cell lithium ion or lithium polymer battery, the Kaonic 1S supports that. We have 2 exposed USB-C ports. One of them has power delivery up to 45 watts. So you could charge a 2S battery at up to 34 watts. So that means a 2S battery, a 5,000 milliamp hour battery could charge in 40 minutes, I believe, between 40 and 50 minutes with the USB-C power delivery. Then you have a micro SD, so of course that allows for file system expansion. We have multiple UARTs, so the UARTs allow you to plug into machines, drones, other things. We have a J11403 connector, allowing you to have audio, so you could create a push-to-talk device with this if you'd like. We have multiple built-in already 2.4 gigahertz antennas. So I'm not sure if I mentioned this previously, but Kaonic 1S has 3 radios, but in a way it's actually 5 because so you have a Wi-Fi Bluetooth, that's one radio, and then you have the 2 RF front ends. And the 2 RF front ends, they can be 2.4 gigahertz or 868 megahertz. And so we have antenna connectors for those if you'd like to connect external antennas. But the 2.4 gigahertz already has the 2.4. We also have internal antennas, so you don't have to connect 2.4 gigahertz antennas. So in the kind of the demo deployment that we're looking at, we have this box with 2 sub-gigahertz antennas sticking out rather than 4, because the 2.4 gigahertz are on the board itself. In terms of other connectivity, you have more USB-C ports. You have an extra USB-C port with a separate data line, which is really important because the other 2 USB-C ports, obviously one you could use for charging as well. You could charge directly the battery that's connected to the Kaonic 1S. But if you want to have multiple data sources, you could connect, USB data to the USB, like your end user device, your Android device. You could connect it via USB, and then you could have another USB port for something else, and then you can have UART for something else as well. So there's a lot of options in terms of expansion and modularity here.
Yeah, it seems like the options are almost maybe not unlimited, but pretty expansive. So that's awesome. This is kind of where you get into like a little bit of, obviously a lot of people that are interested in this type of thing that are in the private sector, whether they're a volunteer that works on a search and rescue team or, some sort of NGO, non-government agency, or private professionals, people that are for hire to do this type of work. What you said, you've already kind of touched on, but range and scalability for urban and rural environments, and then what kind of hardware. It sounds like you could just set up one of these to be, its own node in the network, and basically use it in a fixed location, maybe on a high point as a repeater in essence. But can you kind of touch on that a little bit?
Absolutely. So the idea behind the Kaonic 1S from the radio standpoint is to have the performance of a military grade radio, but with the accessibility of a commercial IoT radio module. So in terms of range, what we're prioritizing is we're actually prioritizing the urban and tactical scenarios. So we're using waveforms, we're using modulations that have a higher data rate and higher higher throughput and higher multipath propagation. So it's going to work better with foliage, with through concrete than LoRa's chirp spread spectrum is going to work. Whereas LoRa really shines in record setting type of scenarios where you stick a LoRa on top of a mountain and then you try to get a distance record. And I've seen people on the internet get up to 350 kilometers and so on with that. That's not what we're targeting. We're targeting a more urban type of scenario. And that's kind of what we want to build. We want to build a global mesh network that you touched a bit upon NGOs. This could allow people to deploy an alternative to telecom that is resilient and requires much less investment to set up a tower. If with just a few satellites around the planet, we could have global connectivity. I'm not saying that we're going to be getting 5G speeds or anything like that, not at all. But for critical data, especially when paired with Reticulum, it's going to be very, very powerful. In an urban scenario, as I mentioned, the Kaonic 1S already has multiple modulations, waveforms to choose from without the FPGA. One of them being OFDM. OFDM is this modulation that splits the signal into multiple subcarriers. But once you add the FPGA on top, you're going to be getting an extra 3 to 4 dB. And with some interesting antenna setups, you could get even 6 dB, which translates to 200% increase in range. So, and that's in urban scenarios as well. So that's super interesting stuff in terms of the FPGA, and we're really looking forward to opening that up to people, see what they can do with that.
Yeah, and then drones. Obviously, we'll talk that here in a bit. But I know obviously adding any sort of aerial platform, whether that's an unmanned drone or an aircraft or something like that, obviously you can always expand networks, over to get past the obstacles like terrain and stuff. So that's cool. Yeah, and as you mentioned, like with NGOs, especially a lot of them, they go to war-torn places with little to no infrastructure, and a lot of times they have to rely on satellite type communications or handheld radios. But having something like this as a capability to build their own little network would be pretty, I think, very important for a lot of them. And I think there's definitely a market space there for that type of device. So going into interface, you guys do have an application, correct, that interfaces with that, and then also ATAC, correct? Or you're working the ATAC plugin side of it?
Yeah. So starting off with the app. The app started off only as a demo app, and the idea with it was it's a open source app to showcase the capabilities of Kaonic, but it's become something a bit deeper than that now because we have quite a lot of security features. We have access controls. So we have passwords to enter. You can set up a PIN to enter. It's very user friendly. It looks like a quite sleek messaging app. You see, the surrounding nodes around you. You can call users through the mesh network. You can send files, and all of this is done in a modular way. What I mean by that is that most of these behaviors are implemented at the library level, meaning that it's a type of code that is packaged and other developers can import into their own apps and use. And what that allows is it allows importing it into ATAC. So you could have audio calls through ATAC. So we just recently, this week, in fact, finished the Java plugin in order
Mhm.
to, and now we're starting the ATAC plugin, which we're very, very excited about because we already have the sample app, which is using the same library that ATAC will use. And one of the very cool things you could do, I tested this myself yesterday. You can send, like, we could send each other files simultaneously, which is pretty cool. The reason we can do that is because at the radio level, we're using an algorithm called time division duplexing. And what that does is radios are kind of each sending for a specific amount of milliseconds each, some data. They're exchanging data, and we're going back and forth. That's most likely how this video call is working as well, using time division duplexing to simulate a live video call. Of course, on Kaonic with MIMO, you could have a full duplex as well. That would totally be possible, where it's actually full duplex and you don't have time division duplexing. But it's really cool to see, live audio calls, simultaneous file sending, stuff that, is you couldn't really imagine on lower bandwidth type of platforms. Yeah. Sorry, I went a bit off track there.
No, that was great information, and I think a lot of people appreciate that. They're just because through whether it's ATAC or through your native app there that you have or interface, that helps remove. I would assume helps kind of remove some of the complexity of the device. So, and now ATAC there's a learning curve with that, but it's getting so widely adopted and across all kinds of just private citizens to government agencies. Started obviously being specifically military, and then now it's kind of just everywhere. You see a lot of people using it for all kinds of stuff. So
everywhere, firefighters, drones for agricultural stuff.
Yep.
Everywhere. It's great to see that.
Yeah.
It would be interesting to see what could be, the next version of ATAC, something smoother, something more capable. New frameworks have come out in the recent years that are leaner in a way. And so, of course, we are also exploring those options. And that's maybe one of the things that, who knows, maybe in the future we will add map functionality to the Kaonic app itself. So maybe that's snappier, faster in a way. But of course, we want to integrate into systems like ATAC.
Yeah, based off of potential users, a lot of people are maybe already used to it, and that's what they're using with the current, mesh radios or whatever they're using to communicate. That'll be an easier, path to those people. And then, because if they don't have to use something new, they can just use ATAC that they've already trained on or familiar with. So, so this kind of next one kind of leads us back kind of into ATAC a little bit, but drones, you already talked about integration a little bit there with the capabilities. I would assume, based off of all the data you've given here, that you could be able to receive feeds from drones if you had it configured correctly, and a Kaonic attached to the drone, I would assume, would be required with that information, unless you have some other radio that's sending those signals to you.
Yeah, absolutely. So with the data rate, there are two options really. It's either with the FPGA plugin or without. So without the FPGA plugin, you could get video. The maximum you'd be able to get is about 4.8 megabits on either band. So either 2.4 or the 900, 868 megahertz band. Whereas if you use the FPGA, you'd be able to get much, much more. So if you don't use the FPGA, you're going to be limited to perhaps 720p with H.265 encoding. So H.265 encoding is a type of encoding that is really good at compressing video, and but it requires a digital camera most cameras have H.264. H.265 is a little bit newer, and requires a little bit of a different type of camera, a little bit more processing, but you're able to get 720p. You'd be able to get, with 4.8 megabits, you'd be able to get at least 720p, which is something unheard of, right? Even 360p would be so cool on radio. So we're really excited to see what people will build. And I mean, even an extremely pixelated video, like you struggle with very much with LoRa to do that. I mean, since you're limited at 56 kilobits. So yeah, Kaonic gives you that flexibility, and especially through Reticulum, you have the mesh networking added on top of that. And so we're conducting some experiments on what's the latency going to be with video. We haven't tested that yet. The video over meshing, we have not tested that yet. But that's in a way why we have open source stuff, so people can conduct tests and see what it is how far can we push this system. In terms of control, so you could easily use the Kaonic as an all-in-one module. So you could send video, you can control your drone, you could receive telemetry from your drone with Kaonic, and all of that could be working over the mesh. And that's super interesting because we are looking at a protocol called Mavlink, and Mavlink is used a lot in the drone space. But interestingly, Mavlink is not encrypted by default. So our implementation of Mavlink is going to be encrypted and digitally signed by default, making it already more secure. And the idea is, again, we want to make it as plug and play as possible. So for any drone enthusiasts out there, the idea would be you just plug your Kaonic into the UART of your flight controller, configure it via Betaflight or ArduPilot, just as you would anything else. And you can obviously plug into the Kaonic via USB or Wi-Fi and change the settings of your radio through the configuration app. So in a way, it's just as plug and play as anything else. In terms of a controller solution, a transmitter to control the drone, I envision people kind of using either mobile devices to control drones, and then those mobile devices are connected to a Kaonic. This is quite a standard setup, or you can connect a kind of joystick type thing to your smartphone and then control the drone like that. I'm sure a lot of people will perhaps want to have a more professional or a different, or build their own kind of controller that has a Kaonic built in. That's going to be super interesting to see. I'm very much looking forward to that.
Yeah, it's impressive. I mean, obviously the only one really in the space that I know of is Doodle Labs. Seems like they're working, or they have some radios that kind of fall into that space as far as being able to do drone stuff. They have their Mesh Rider series and have specifically like a small one that's designed to be integrated with a drone. But I do know that the price point of Doodle Labs, their Mesh Rider series, is quite expensive, and it's all closed source, proprietary. So I think you're gonna get a lot of people that are interested in what you have because of the fact that people like to be able to tinker with stuff and make adjustments and fine tune it to what they want to use it for and make their own custom setup. So that, I think there's a lot of benefits to that. So, and I know there's a lot of people in the world that feel the same way. So I think you're really onto something here with this Kaonic 1S. So you did kind of mention already earlier there was future projects. You're already working on a few. Is there any that you want to highlight here before we wrap up?
Well, mostly we are focusing on optimizations for Kaonic. There's so as I mentioned, a lot of updates for the FPGA where you can double the effective data rate that we're seeing just without the FPGA. So that's going to be super interesting. Then time division duplexing and different algorithms. We are seeking to, once we reach a more stable kind of board that we know we won't want to change anything with, we're going to pursue CE and FCC certification as well. Right now, it's it's like an open system. And in terms of other projects, we're definitely looking at making something much smaller. I think the most interesting thing of all is going to be once we port Reticulum to an MCU, and we're so excited to provide that to the community. We could see Reticulum mesh networking working on a micro device. So that's going to be super, super interesting. And we're already working on that. We already have, we're already working on the layout for the PCB of such a device using beefy MCUs, but MCUs nonetheless. And that would allow, it would be a very, very small device. So I'm talking about size of other radio modules, but you are going to have 2,500 kilobits per second as your limit instead of 50. Then you have to, so that's going to open up some doors. And I think that people might even use that module that we're going to be coming out with, the Kaonic 1 Lite. The Kaonic 1 Lite will only feature one radio, no FPGA, no second radio, no second RF front end. It's going to be just the one RF front end basically, and an MCU running Reticulum. And the idea with it is going to be able to provide, much more throughput than LoRa can. And I think something really interesting might be even combining LoRa and the Kaonic 1 Lite. You could use the LoRa device for very long range, projects, and then once or deployments, and once you get closer in range, it switches to the Kaonic 1 Lite, and you're able to use that higher data rate, but still with the good sensitivity that something else might not have. So yeah, those are some of the projects, mostly protocol improvements and making things smaller and more affordable for people to use.
Very cool. Yeah, I could see, when you get something smaller, that you start integrating multiple, radio types into one device would be something I think it would definitely take the whole radio space by storm, just because right now we really just haven't seen a whole lot of change in two-way communication devices. Obviously our cell phones are those, but they rely on a very centralized infrastructure that is shown time and time again that it is very vulnerable, and when it goes down, people are left in the dark per se for as far as communications go. But yeah, that's really cool. And is there anything else you want to add before we wrap up? Do you want to? You probably afterwards you can provide me any sort of links that you might want to provide. I don't know if you use GitHub or anything like that for the open source stuff.
Yeah, absolutely.
Anybody that watches this, it might want to go in there and see the code and stuff and look at it and start tinkering. But and then I'll put those, of course, in the comment section or the description section down below the video. So anything else you want to add?
I guess, we're just really excited for people to build stuff with what we've been able to build at this stage. And that, follow us on GitHub, check out our code, and let's decentralize communication.
Absolutely. I can agree with you more. Super excited to have you on. Thank you for coming on, Nicholas. And, look forward to communicating with you more in the future. So thanks a lot.
Wow, what a fascinating and great interview. Thank you, Nicholas. Thank you, Victor, their Chief Sales Officer, for reaching out, setting this all up. This is a relationship I hope to continue to build on. If you want to check out the Kaonic 1S, I'll provide the links for their website down below, their GitHub. So if you want to check out the code, if you're interested in that, you want to be a contributor to that, you can go check that out there. The price point of these, I think, is about currently their sales price is about €1,000. I'll do the conversion, put it here in the video for USD, at least as of today. You know, those fluctuate, but it is a radio that mesh radio that provides you above many of the others, way above many of the others on the market. If you're a Meshtastic user and you don't need this capability, it's probably not something you're going to be willing to spend your money on. If you're looking at something like the Beartooth Mark II, you're looking at something like Doodle Labs Mesh Writer series, this device has more capability and a lower price point. So take that in consideration. It even has, at least on paper, has more capability than most the military grade SDR type radios that are being used today at a much lower price point. You know, you're talking 10,000 plus on a lot of those radios. So if that's something you're looking at, let me know in the comments. Tell me what your questions, concerns, whatever those may be. Don't forget to subscribe to the channel if you like this type of content. We're hoping to do more interviews like this in the future. If you're interested in coming on and doing an interview to talk about mesh radios, emergency communications, whatever that may be, something in our wheelhouse, let me know, reach out, and we'll try to work something out there. Thanks for watching. See you next time.